Alright, today we're going to talk about squares and rhombi. We'll start with the rhombus. A rhombus is a parallelogram with four congruent sides. So it's a parallelogram, so everything we've learned about parallelograms is still true. Here's a quick recap of the 5 things that we've learned about parallelograms already. Opposite sides are parallel and congruent. Opposite angles are congruent. Consecutive angles are supplementary, and the diagonals bisect each other. So those things are true about all parallelograms, and so they're true about every rhombus, because a rhombus is a type of parallelogram. In addition to all of the properties of a parallelogram, a rhombus has 3 additional special properties. They are: the diagonals are perpendicular. Remember, perpendicular means that they intersect to form right angles. So right here, the diagonals are intersecting at this point. Each of these angles that's created by those diagonals has to be a right angle. The diagonals are perpendicular. The diagonals bisect opposite angles, so it's bisecting this angle and this angle, and this diagonal is bisecting this angle and this angle. Remember, bisect means it splits it into 2 congruent halves, so I'm taking this larger angle and splitting it into 2 congruent parts here. Taking this angle and splitting it into 2 congruent parts. And finally, a rhombus has 4 congruent sides, as we read in the definition. So I know that all 4 of these sides are the same length. So there in the picture, I've marked all the things that are unique to a rhombus. But remember, all those other things about a parallelogram is also true. Get a little messy for me to put it all in there right now. But alright, so let's look at example 1, and let's see if we can take this information and apply it and use it to solve problems. So it says, if the measure of angle RST is 67 degrees, find the measure of angle RSW. So RST, this entire angle up here, is 67 degrees. Now remember, we just learned that diagonals bisect opposite angles in a rhombus, which it tells us it's a rhombus. So that 67 degree angle is going to be bisected, split into 2 congruent halves. And angle RSW is one of those halves. So we're simply finding out what half of 67 is, and you should get 33.5 degrees. Measure of angle RSW is 33.5 degrees. Alright, let's look at example 2. Find the measure of angle find the measure of angle SVT, this angle right here, if the measure of angle STV is 137 degrees. So this angle right here is supposed to be 135 degrees. Alright, remember, in all parallelograms, consecutive angles are supplementary. So this angle and the entire angle down here have to be supplementary. So that means they add up to 180. So if I subtract 135 from 180, I find out that this entire angle down here has to be 45 degrees. Now, what I'm actually given an answer for is the measure of angle SVT, which is not this entire angle down here. It's not angle RVT. It's only half of that. And I know it's exactly half of it because, again, the diagonals bisect opposite angles in a rhombus. So I know that that 45 degree angle is being split into 2 congruent parts. So half of 45 is 22.5. So I know that that angle is 22.5 degrees. Alright, let's turn the page. Example 3. If the measure of angle SWT is 2x plus 8, find x. Well, notice that that's one of the angles created by the 2 diagonals, SWT. It's created by the 2 diagonals. And remember, one of the things we just learned about a rhombus is that the diagonals are perpendicular. So remember, those diagonals form nothing but right angles. So that includes this angle right here. This is a right angle. A right angle is 90 degrees. So that 2x plus 8 has to be 90. It has to equal 90 degrees because the diagonals are perpendicular. So then it's just a process of solving the equation. We find out x is 41. Okay, let's try another one. What is the value of x if the measure of angle WRV is 5x plus 5, WRV, this angle right here, and the measure of angle WRS is 7x minus 19. Remember, in a rhombus, the diagonals bisect the angles. So, this larger angle, angle SRV, is being bisected, split into two congruent parts. So these expressions they gave me are for angles that are going to be congruent to each other. And when things are congruent, we set them equal to each other, because congruent means equal measures. So then we're just solving the equation, just solving for x. Don't want x on both sides, so I subtract the 5x to get rid of it on one side. Once I got x in one place, I want to get it all by itself. Got to move the 2 and the 19. I'm going to always start with the constant. Always start with that number that's by itself. Since it was being subtracted, we'll do the opposite and we add it. And then I get rid of the 2. X is being multiplied by 2, so we do the opposite and we divide by 2. Alright, one more. Use rhombus DLMP with the distance from D to M equaling 26 to determine whether each statement is true or false. Justify your answers. Okay, well, I want to label the picture. Labeling the distance from D to M is a little tedious or a little difficult because it's split into two parts. But I remember that in all parallelograms, diagonals bisect each other. So if this entire diagonal excuse me, is 26, I know that it's going to be bisected into two congruent halves, and half of 26 is 13. So I'm going to label it 13 and 13 to get that total of 26 all the way across there. Now let's read the statements over here and see if they're true or false. So A says the distance from O to M is equal to 13. And that's just what we did. We labeled that as 13 because OM is half of line segment DM, and half of 26 is 13, so that is true. Line segment MD is congruent to line segment PL. We do not know that these diagonals are congruent. We know that they bisect each other. We know that they bisect opposite angles. We know they intersect at right angles because they're perpendicular. We don't know that they're congruent. We learned that diagonals were congruent when we were dealing with rectangles, but a rhombus is not a rectangle. It can be, and it's a very special case we'll talk about in a second, but most of the time it's not, and so most of the time this would not work. So this is false. Alright, and the other statement, the measure of angle DLO is equal to the measure of angle LDO. Okay, these two angles are not necessarily going to be congruent. Their measures are not going to be equal. The angles are bisected by the diagonals, so I know that this angle and this angle are congruent, and I know that this angle and this angle are congruent because this angle is bisected into two congruent halves and this angle is bisected into two congruent halves, but I do not know that these are congruent. So this is false. Alright, so let's talk about a square. A square is a parallelogram that is both a rectangle and a rhombus. So we've talked about polygons, quadrilaterals, parallelograms, rectangles, and rhombi. And a square falls under all of these categories. So everything that we've learned about all of these things applies to a square. So we've got quite a few things that we know are always true. It's very consistent with a lot of things that are the same. So, because it's a type of parallelogram, we got the 5 things that we learned about parallelograms that are true. because it's a rectangle, we got these two things that we learned about rectangles that are true. And because it's a rhombus, we got these three things that we learned about a rhombus that are true. So all of those things come together as one shape in a square. All of those things are true at the same time for a square. So I'm going to attempt to label most of that in the picture. Some of them will be kind of combined. So let's think about the sides first. Because it's a rhombus, we know that it's got 4 congruent sides. So that covers the fact that opposite sides are congruent as well. Also, opposite sides are parallel. So this side and this side are parallel. This side and this side are parallel. Okay. It's got 4 right angles. This is a right angle, right angle, right angle, right angle. Okay. Now, that covers the fact that the opposite angles are congruent, because right angle and right angle, those are going to be congruent. And it covers the fact that consecutive angles are supplementary. 90 plus 90 is 180, so those are going to be supplementary. But this is a right angle, and the diagonals are going to bisect the opposite angles. If you have a right angle 90 degrees and you bisect it, half of 90 is 45. So when you take a right angle 90 degrees and bisect it, you get 2 45-degree angles. Over here, right angle bisected, 45 and 45. And that happens at each vertex. This angle is bisected, it was 90, 45 and 45. I'm just writing these in everywhere. And then also remember the diagonals are perpendicular. So right here where these diagonals intersect, forming right angles. Nothing but right angles. And then also the diagonals bisect each other and the diagonals are congruent. So because these diagonals start out as the same length and they're both bisected, they're split into 4 segments that are all congruent. So this is essentially what you end up with every single square, is the information that I have on the picture right here. If you draw both diagonals in, you end up with 4 45, 45, 90 triangles, referencing their angles there. 4 congruent 45, 45, 90 triangles. Alright, so let's take the information we know about a square. We didn't learn anything new, but it's a combination of things that we already learned in one. So a rectangle and a rhombus at the same time. Alright, MATH is a square. If the distance from M to A is 8, then the distance from H to T is, well, all 4 sides of a square are congruent, so it would have to be 8 also. The measure of angle HST, remember that the diagonals are perpendicular. Because it's a type of rhombus, that's one of the things we know. Diagonals are perpendicular, so that has to be a right angle. So angle HST is 90 degrees. And then measure of angle MAT. MAT, also a right angle because it's a type of rectangle, and a rectangle has 4 right angles. So that is also 90 degrees. And then if the distance from H to S is 2, then we want to know the distance from H to A and the distance from M to T. So first off, remember the diagonals are both congruent and bisecting each other. So all 4 of these segments are going to be the same. So if that's 2, so is this one, so is this one, so is this one. So now what is the distance from H to A? Well, it's 2 plus 2, which is 4. And the distance from M to T, again, 2 plus 2 is 4. The 2 diagonals, HA and MT, those 2 segments, are congruent. So they're both going to be the same number. Both going to be 4 in this case. Alright, let's look at example 7. Use square ABCD and the given information to find each. If the measure of angle AED is 5x plus 5, find x. Well, this is an angle that is created by the 2 diagonals. And remember, we learned that the diagonals are perpendicular, so they're not going to form anything but right angles. So this is a right angle. So I know that 5x plus 5 equals 90. and then we just solve the equation. So we get x is 17. Okay, looking at B, it says if the measure of angle BAC is 5x, we want to solve for x. Well, remember, this is a right angle because all four angles of a square are right angles, or any type of rectangle. And remember, because it's a rhombus of some sort, a square is always a rhombus as well. One of the things we know is that the diagonals bisect the angles. So remember, that right angle is going to be split in half, 45 and 45. So I know that that 5x equals 45 degrees. So solve for x. There it is.